So we are here at Smurf in jolly old England, and we're going to talk about a topic that's going to scare the Australians, because we're going to talk about EMU, although it's a filament multi-material system and not the bird. So we have Yannis here who's going to show us what the bird's all about.
All right, so the whole concept behind the expandable multi-material unit is make as many lanes as you want, as simply and as easily as possible. The whole concept is based off the filamentalist passive rewinder. We have integrated a stepper on the assembly, classic BMG gear, bearing drive, sort of one-way bearing here that is used to drive the wheels. So you put your, basically put your filament in, yeah, and that is used then to lock up the bearing and drive that. And,
so as the filament's being fed into the printer,
it unlocks.
It unlocks, so it's not spinning
exactly.
these.
So it's not spinning these, it moves over, and then the stepper rewinds, and then this one grabs hold, and then it drives the assembly.
So that's how you're driving your motors here. So there is no additional motor. So
exactly.
You're simplifying it, and also it's quieter than having a stepper motor going.
It's simple. I mean, for me, the biggest thing is keeping things simple. So keeping simple means making things reliable. So there's less things to go wrong. So there's less electronics within the unit. So it's only one stepper, highly reliable, very simple mechanically. Also, as you can see, several sensors are used on the unit in order to know sort of where the filament is.
Yep.
So the first two are used to sort of identify a filament being present in the unit. Second one is basically the filament homing point, which is used to identify where it's ready to start loading, and then back on the back of the unit and into the toolhead. So yeah, that's the core mechanics of it. It's a very simple, kind of neat assembly.
And it's all 3D printed?
Everything's 3D printed, off-the-shelf hardware. I mean, the most complex thing is the one-way bearing, really, and that's sitting in between here, and the stepper.
Content from this year's Sanjay Mortimer RepRap Fest is sponsored by LDO Motors. For printer parts, kits, accessories, and more, check them out at the link in the video description.
So then the concept is that you can make as many lanes as you want. So you can use one lane if you just want to do just a passive filament feeding into the unit, so like a filament follower. Or you can move to 2 lanes if you just want to do filament failover and swapping.
Yep.
Or basically as many as you want. At home I got an 8 lane just because I like keeping 8 filaments available and ready to go. So the unit is based of the electronics are based on an EBB 36 board or a 42 board. Standard, basically cheap toolhead boards, all wired over CAN bus.
So each unit is basically independent, and then they all talk together over CAN bus.
Exactly. Every unit, so its own electronics, its own wiring, standalone, fully isolated, and then just sharing power and the CAN bus network that is used for communication, right?
These are also dry boxes too, right?
Exactly. So let me show you all the tricks here. So you get your desiccant assembly, and then each one of the units has a fully sealed design. So there's a gasket around here, as well as a gasket inside the plexiglass panel that's used, for visibility, and then also similarly underneath where you saw the hatch board sort of being, all the wires coming through.
Yeah, you have the PCB here, so all the wires go through this PCB to help seal it up, so you're not just running holes.
Exactly, and all the sensors come in, so you've got your pre-gate, post-gate sensors, your ITC sensor for temperature and humidity monitoring within the box, so one basically BME sensor, SHC sensor per lane, and then also your stepper motor. Personal experience, I've been using this we started developing this since July together with DW Taz, who's sort of the primary CAD designer and creator. And I've been running this basically since July. Highly reliable, very little sort of maintenance, very little things to go wrong. As you saw, it's a very simple design, bottom line. And now we're in the process of sort of refining the design, making it a bit more production ready. So as you can see here, we've got some sort of interesting LED effects going on with some custom boards that we have just developed. Just makes it look nice, a bit more fancy. It kind of shows you now it's rewinding back into the unit. Then the PCB board for the hatch. Again, simplifies wiring because every sensor's got its own port, standard JST connectors, and nice labeling and all sorts. And then the other thing we have developed, if you want to come on the back side, is this sensor here. So you can see here is the passive combiner, no electronics, single CAN bus in, and then this thing here, which is the filament proportional sensor. So you can identify the exact amount of pressure within the Bowden tube. And bottom line, what it does is it keeps the MMU and the extruder precisely in sync.
So this is looking a little bit more advanced than your traditional, because your traditional ones are usually just an end stop on each side. So you're seeing it bounce back and forth. This is kind of holding it in the middle here.
Exactly. And this one's using a Hall effect sensor to measure the displacement of this unit versus the central line, and then in real time adjusts the rotation distance of the unit proportionally to how far away this is off center.
Okay, so it's feeding the filament on the fly instead of waiting for that
exactly
end
waiting
stop
for the
to activate,
sensor to
then feed a bunch,
and then come back again. Exactly. And what's really cool about this, it can do real-time clog and tangle detection. So if it detects that the filament's kind of sitting on one side for too long, it's going to say, oops, something went wrong with the print, and it's going to pause it, allow you to intervene, recover, and all that. Yeah?
That's very clever.
Yeah,
and I'm assuming there's like a
cool
custom PCB in there for
Exactly. It's a very small custom PCB that kind of plugs into here, 3 wires, and into the thermistor port of the ABB unit. So again, no additional electronics.
Oh, nice.
Yeah, and very reliable. With the whole trickery really being in software. So Moggy's done a fantastic job in developing an extended Kalman filter, basically a PID tune for your rotation distance, auto-calibrating how quickly this thing should move in order to match the extruder.
Nice. And everything here is also all 3D printed. So if you wanted to build these yourself, you can customize the colors and do all that
absolutely. You can do what you can do. Exactly. So all DIY, all 3D printed. As I said, mostly off-the-shelf hardware, switches, bearings, screws, the box. Nothing really crazy, nothing really highly custom. As I said, off Toolhead boards, easily available off, I don't know, BTT or whoever else is sort of your fancy. Now this sort of pairs up quite nicely with DW Taz's A4T Toolhead, personal favorite. So it's been tweaked and optimized for multi-material use. There's a few little adjustments. So first of all, you're going to see the crossbow cutter here. So it's a CNC filament cutter, the actuation pin, and then the wristwatch BMG extruder with 2 sensors, one before and one after the gears, so we know exactly where the filament is if something went wrong, and be able to troubleshoot sort of on the fly. And again, as you're going to see now, it's going to start its purge routine. It's using the blobifier and creating little pellets after so the load finishes. And on the rear, there's a little brush. Make sure the nozzle is nice and clean and sealed while it's doing its filament swap. So you'd basically get no zits, no marks on the print, no oozing or stringing.
And then this printer here, it's based on a V2, but we got a monolith gantry here.
Yes.
Okay, and then we got the V2Z. So it's kind of a semi-custom printer.
Exactly.
Here
So it started off as a classic V2. Then slowly, as I was seeking a bit more performance, a bit more, make it look a bit more elegant, a bit nicer. So used the Harticase design, took the new skirts that are published for Trident, made them for a 2.4, and then a monolith gantry on just for slightly better accelerations and a better input shaping. So screen. So I don't personally enjoy having a screen on my printer. I like it having it a bit further away. Why? Because the printer is usually on the floor, and it kind of hurts my back. So screen again, basically a Raspberry Pi, a USB 3 board, just provide power, and this one's using Helix Screen, which is brand new software, sort of replacing the traditional clipper screen, a bit more modern, but still so highly beta. You can see filament consumption, how much I got left, the topology of the MMU, and so forth, right? And spool information, how much I got left.
That's cool.
Material, what color, and it's really good. It's exactly what you need, just be able to control the printer.
Awesome. And where can people find more information about the EMU system?
Absolutely. So 2 places. So dwtaz.net. You can find all of WTaz's creations, and then on the EMU site on GitHub, pretty comprehensive, both video guides for how you're going to assemble it, as well as all the CAD files, STL files, bill of materials, setup configuration, and so forth.
Awesome. That's really cool. Thank you, Yanis.
Thank you.
Cheers.
Cheers.